Hello everybody, my name is Michael Salzberg and welcome to my computer performance modeling tutorial. Before we dive into all the details, I'd like to take a few moments and discuss with you the motivation as to why computer performance modeling is necessary and adds value to your job. So let's get right into it. If you take a look at this slide that I'm showing to you right now, you'll see that the days where we felt that 10-second response time was sufficient are over. It used to be that when we were looking at computer performance and modeling computer performance, 10-second response time was considered acceptable. And that was mainly because the users of computers were accountants, bankers, people in the back office. But today you have end users who directly are interfacing with computer technology, and 10 seconds is not sufficient. They want to feel like they're in control of what's going on. So the new normal now is 0.1 seconds. Now, when it comes to computer response time, you may be asking yourself, why do I have this tutorial, this long tutorial, that's going to focus on response time when it seems pretty simple? And really, why not just get an Excel spreadsheet from someone else who's done it for a while and run it with some data and you're done? Well, response time is an issue because it's a nonlinear function. And what do I mean by that? If you look at workloads such as someone who's loading a truck and they're loading it 10 boxes a minute and you want to load 50 boxes a minute, then it's a linear function. You add 4 more truck loaders, you can load at 50 boxes a minute. But that's not how it works with computer performance, because what you're talking about is a single resource or a set of single resources, each of which has a queue. And you have requests for work that show up in a random manner. And you cannot assume, as I'm showing here, that if you had 5 transactions a second with response time of 1 second, if you double the CPU power, well, you could do 10 transactions a second and still remain with your 1 second response time. This graphic shows you what I mean by non-linearity. So if you look at response time in this graphic, you're going from, with 0 utilization, you could have a response time every, if there's an arrival every once in a while. That's rather low. But what happens is, as the utilization increases towards 100%, there's this nonlinear function where there's more and more queuing in front of the server. And eventually you get to a point at 100% where you could wait an infinite amount of time before you get served. There's a little teaser on the right that shows you for different distributions of service. Actually, that non-linearity changes, and we'll address that later on in the tutorial. So here's the summary of the entire tutorial to give you an idea of what I'll be covering. First of all, we already talked about the motivation. Then I'd like to go into the history of computer performance modeling, and you'll see that it has a very rich history. Then we will cover the fundamental concepts and models for computer performance evaluation. We'll discuss workload distributions, which is a little geeky, has a little bit of Greek in it, some statistics and probabilities and stuff. But I promise you it won't hurt too much. Then we'll go to applying computer performance modeling to an example. We'll go from that to talking about simulation modeling, which is a second approach to do computer performance modeling. And then I'd like to spend some time showing you the results of a recent modeling project, which I think you will find interesting. So let's move on to the history of computer performance modeling.